All right, so there's only a few more things for us to go through from this packet, and then we're done this entire unit. And remember, there are things now that will be assessed and put on your report card, and then the other things that aren't part of that standard are going to be used for exceeding. So you have those listed out for you in your assignment for today that says what you must know that's going to be graded and count it towards your report card, and the other things that can help you show me exceeding because it's things beyond what our standards are asking for and what we're being asked to do for this year as well. So the last few things that we need to go through are the distance formula, and we're going to go through this in a question. And then after that, there's three other things: adjacent angles, linear pairs, and vertical angles. So for adjacent angles, it's just pretty much being able to identify them and name them. Whereas linear pairs, not only, and vertical angles, not only do you have to be able to identify and label them, but there are specific rules that happen with them that allow for us to solve problems as well. But let's go ahead and start with this distance formula. And we already kind of talked about, not already kind of, we did talk about what these x2s and x1s and y2s and y1s means. It's like when we have the same two people with the same name, and it's allowing for us to then differentiate between, I think you guys said that there was a chi-r and a chi-s. So it just allows for us to know exactly which one we're talking about. Because if I write an ordered pair xy and then another ordered pair xy, well, how do I know which one we're referring to if I just say X? So just like we can say chi S to refer to him or chi T to refer to them, we can then say, well, I'm going to label these X1, Y1 and label these X2, Y2. So this way I can say X1 and I know we're talking about this order pair, or X2 and I know we're talking about this order pair. And remember, we can't mix up the X1 and Y1, and I can't say that this is Y2 because then we're giving them two different names and we're giving them two different placements and saying, oh, well, this X is part of our first order pair, but I'm switching it for the Y. So we just need to be consistent. And then the other thing that you need to make sure that you're mindful of with this formula is that it's minus and minus. And when we go to do a problem, I'm going to show you where a lot of common mistakes are with this. All right, so let's go ahead and do two different problems for this in a way that they can be presented. Actually, we're just going to do one problem. And if you guys need any more extra help from this, I'm going to have a couple videos that I've made in the past that go in way more detail of explaining this. So you guys can watch that only if you want to. This is the only one that's going to be mandatory. But sometimes it can be presented to you in a graph, and sometimes it's just going to be presented to you as points, A and B. If it's in a graph, sometimes I won't give you this, but you will have to identify that first. And I'll just say that this is point B. And the way that we know our ordered pair for point B is we move horizontally for X. So 1, 2, 3. I see that this point is along that 3 for X. So that's why 3 is there. And then we can count up 1, 2, 3, 4, 5. And I know that that B is 3, 5. And then for A, we can, if it's not given to us here, we know it's 1, 2, 3, 4, 5, 6. So it's a positive 6. And I'm going down 1. So that's why it's negative 1. So sometimes it will be given to you like it is here. Sometimes it won't be giving you the points. You'd have to actually count them out. Or sometimes it's given to us in order pair. But the way that we represent distance is just writing AB without any other symbol, the line segment, anything above it, anything next to it. It's just saying this is the distance of AB. Sometimes you might see these lines here next to it as well. But for us, you just need to write AB. And then our formula is the square root of x2 minus x1 plus y2 minus y1. And then we're squaring both the x2 minus x1 and the y2 minus y1. And now, so if we're going to have these x2s and y2s, we're going to go ahead and have to label them. I'm purposely labeling this one x1, y1, just because I want to practice what happens when we have a minus for a number that we need to make sure that we're doing. So then we have x2 and y2. So now I'm going to plug it in. Well, the distance of AB is equal to the square root of x2, which is 3, minus x1, which is 6, so minus 6 squared, plus y2, which is 5. And our formula is minus. A lot of times when students see this minus in front of the 1, they just write minus 1. But since our formula has a minus sign built into it, and our y1 value is negative 1, it needs to be minus a negative 1. And then we square that. So make sure that when you're doing this, I highly suggest, actually, let me go ahead and erase this part. I highly suggest that when you are substituting it in, that anytime it's a negative number, put a parentheses around it, because then it can help you differentiate from the formula and the number that's negative. And now we're just going to go ahead and you can use your calculator. We're going to go ahead and solve this. So AB is then equal to, well, the square root, well, 3 minus 6 is -3, so -3 squared, plus minus a negative turns to a positive, so plus 6 squared. And now we're just going to go ahead and keep simplifying. So AB is equal to the square root. Well, -3 squared is +9 because -3 times -3 is equal to +9, a negative times a negative, plus 6 squared is 36. And now we're just going to go ahead and continue to solve this. So AB is then equal to the square root of 45. And then from here, just plug this into your calculator, and it will tell us that AB is then equal to 3 times the square root of 5. These are the same value. It's just simplifying it for you, or just like it would simplify 4/8 is equal to 1/2. This is just rewriting it in its simplest form. We're not going to assess on how to reduce radicals right now. It is something that maybe later on in the year that we'll cover if we have time to help you for your future maths. But for right now, you should have learned this before in grade 8, actually. But if you don't remember it, you're allowed to use a calculator, and that will go ahead and do it for you. All right, but then our distance is 3 times the square root of 5. Or if you plug that in your calculator, it gives you a decimal value, whatever that value is as well. All right, but this is how we find our distance between 2 points. It can be given to you flat out as points here, and you just pick them x1, y1, x2, y2, or it's given to you as a graph. These are the ways that it will be presented to you. We're going to go ahead and just finish going over these other key terms. So adjacent angles are two angles that share a common vertex and side, but have no common interior points. So what are interior points? If this is an angle, interior points are all the points inside that angle. So anything I can draw inside that angle, whereas our exterior points are anything outside of it. So adjacent angles are two angles that share a vertex. So that means that they need to grow from the same common point. So let's just go ahead and write, here is one angle that's being drawn from that vertex. And then here's another one that's being drawn from that vertex. So here we see that they share this common vertex and they share a common side. So this purple line is one that they have that they're sharing. And it says no interior points are shared. So all these red points are the interior angles of this top one, and all of these orange ones are the interior angles of this bottom one. So as long as there's no overlap, then they are adjacent angles. And think about when we learn the angle addition postulate, those are adjacent angles because the two smaller angles add up to the larger one. So if this is angle 1, and this is angle 2, well, angle 1 and angle 2 are adjacent. If we give these points to give them a name, let's say A, B, C, and D, well, these are angle ABC is adjacent to angle CBD. So they can't overlap. And one of the ways that we can remember thinking about it is they're directly right next to each other. And if we were given information, then we can use this to solve for the angle addition postulate. If I couldn't apply the angle addition postulate to it, then they're not adjacent angles. So they need to be directly right next to each other and no overlap. So even though angle A, B, and D shares a vertex and a side with angle CBD, CBD would be inside of this ABD angle. So therefore, they're not adjacent because the one is inside of the other. All right, so this can't be inside of each other. They need to be directly next to each other, like next door neighbors where they share a fence to their house. All right, the next one are linear pairs, and we already kind of talked about this. And these are angles that form a straight line and are supplementary, because we talked about angles that form a straight line and are linear pairs. Well, linear pairs are just sides of an opposite ray. So here are opposite rays, and they share a side, and they form a straight line. So the difference when we are saying a straight angle, that is just one angle that we're kind of talking about there. Linear pairs, it's two adjacent angles. So that means that they share a vertex, they share a side, but when those two come together, they form a straight line. So a linear pair is kind of what it sounds like. It's a pair of angles that form a line. Right? And we know then that these two, if this is angle 1 and angle 2, that the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees, since it does form a straight line. So we know that those two come together to form a straight line, which means we can use that to solve angles or for variables, because we know that they have a very specific characteristic that they form a straight line, which means they add up to 180 degrees. All right. And then the last one is vertical angles. And two angles are vertical angles when their sides form two pairs of opposite rays. So what happens here is from this point of this vertex, here is one opposite ray that is being formed, and here is another opposite ray that is being formed. So in this case, I'm going to number these: angle 1, angle 2, angle 3, and angle 4. So it's two sides or two angles that form opposite rays, and they have a common endpoint. And the vertical angles then are the angles that are directly across or opposite of each other. So here, angle 1 and angle 3 are vertical angles, and angle 4 and angle 2 are vertical angles. And one of the things that happens with these is vertical angles are always congruent to each other, meaning that they're always equal. So that means angle 1 and angle 3 will have the same angle measurement. So if this is 50 degrees, well, then angle 1 also has to be 50 degrees. And then that also means that angle 2 and angle 4, since they're vertical, are also congruent. So that means if angle 2 is 130 degrees, then angle 4 is also 130 degrees. All right, so this is something that's going to be important that we're going to go over next after we finish this unit, because we're going to be talking about transversals, and that is actually part of your standard as well. So it's important for you guys to be able to understand these vertical angles for us to then be able to understand why the next thing that we're going to learn is true. All right, so vertical angles are just angles that are formed by two opposite rays, and they're directly across from each other, and they're also equal. Once again, I have a video that I'm going to post that I've made for classes in the past. I kind of dive into these a little bit more. So if you need that, go ahead and watch that. If you understand this, you can get started on your work now.